All right, so this video is on modeling some real-world exponential growth or decay because we need to recognize that exponential growth or decay is the best model for a variety of different things. So you need to be thinking about how do exponential functions model real-world problems and their solutions while we're going through this. So just a basic reminder that we have this equation, which is y equals a times e to the kt. Y is the ending amount of whatever I'm talking about. Could be people, rabbits. We're going to talk about some different minerals and those types of things. And then A is my beginning amount, what I started with. And then K is your growth or decay factor or rate. And if K is positive, then we know that we have growth. And if K is negative, then we have decay. And then it looks like I don't have it on there, but T would be time. So make sure you write down that that's what T would stand for. Okay. Now, the first example I'm going to do, we actually are going to go back to something that you've kind of seen before. So Jim invested $1,500 into his credit union account, which pays interest compounded continuously. Sorry, you can't see that. After 10 years, his account has grown to $2,260. Find the interest rate rounded to the nearest 1/10 of a percent. All right, so I would go through and I would say this $1,500 is going to represent something that I need in my equation. Okay, 10 years would represent something I need in my equation. The fact that his account has grown to $2,260 represents something I need in my equation. And the fact that here says find the interest rate, I know what I'm looking for. So if he invested $1,500, then I believe that that would be his beginning amount. So if I'm going to use this equation, I think A should be $1,500. So I'm going to go ahead and fill that in. Okay? Now, after 10 years I believe represents time, so I'm going to fill in the time. K is supposed to represent either the growth or decay amount, and because he starts with $1,500 and he ends with $2,260, I know that I'm going to be looking for K, and I also know when all is said and done that K should be a positive number. He increased his amount of money, so if I don't end up with a positive number for K, then I'm going to know I went wrong somewhere. Then here I still have one unknown, but we can only solve for, or I still have two unknowns, but we can only solve for one. So this $2,260, that must be his ending amount. All right, now I have this equation. It looks like a logarithmic equation. And I dropped my E, people. All right, I was wondering why that looked so weird. Okay, don't forget that we are doing exponential growth, so I have to have my E. Okay, so first thing I'm going to do is I'm going to get this term that has E by itself, which means I do not want to multiply it by 1,500. So I'm going to be doing dividing by 1,500 on both sides. Okay, now I recognize that this is an exponential function, so I know that to undo an exponent, I'm going to take a logarithm. I also know that because that's base e, I'm going to use a special case logarithm, and that's going to be the natural log. So I'm going to take the natural log of both sides. I know that 2,260 divided by 1,500, I'm going to take the natural log of that, and that's going to be a number I'm going to use my calculator for. The natural log of e, those are going to undo each other, so I'm just going to be left with 10k on that side. And to finish solving this equation, I am going to divide both sides by my 10. So, exact answer is the natural log of 2,260, I keep forgetting that 6, divided by 1,500. All that divided by 10 equals k. Some of you need to remember to be super careful when you're doing this in your calculator. You're forgetting a lot of parentheses. All right? So, I'm going to do the natural log of 2,260 divided by 1,500. I'm going to remember to close the parentheses because I want them to divide, then evaluate my division. If you leave off that parenthesis, it will not do that. Then I want to take that and divide it by 10. And I have got a small decimal, but then I remember K stands for my rate, so that is a percent, and I want to write that as a percent. So it would be about 4.1%, because I believe my question asked me to round to the nearest tenth of a percent. So his interest rate was about 4.1%. Okay, so these problems are going to be all about reading through a problem, a scenario, and picking out the information that was given to you, knowing where that information goes in our formula for exponential growth or decay, and figuring out which of those is your unknown, because that can change. I could ask you to solve for any of these variables, so you need to know what all of them represent and then be able to fill in what you're given. We will do a couple more examples in class, but this should be enough to get you started. Remember, we're modeling exponential growth or decay of some real life examples.